Now students, gravitational force. Yes, I have told you in earlier slides that the gravity and gravitational force are two different things. So what is gravitational force here? It is the force that is applied by every object in the universe. Gravity is the term that we are only talking about the earth, but here gravitational force is a huge thing. Okay, so when we are talking about the gravitational force, that means we are talking about the every part of the universe. Okay, like here we are having lots of celestial bodies, we are having planets, we are having stars, we are having meteors. Okay, so each and everything here that is available in the space into the universe outside. So we can say that each and every object here are having their own mass, are having their own capacity and content. So every object which is having its mass, okay, mark my word, every object that contains certain mass contains gravitational force. Okay, जिस भी object में even this marker is having certain mass, so it will have certain gravitational force, and that gravitational force we can judge with the formula like F is equals to m multiplied by a. Okay, that's the formula that we have read in the previous chapters. Okay, so but with this thing we can say that the mass here is very low, and with this less mass we cannot afford to attract a lot big things towards itself. Yeah, it is having its own gravitational force, but that too is very less that we can neglect it. Okay, so here what we call about the gravitational force, that we are taking the examples of the planets and the solar systems and the galaxies, that how the sun attracting the planets towards itself, and these all planets are revolving around the sun like this. So not like this, not only this one, but also other planets that are available in outside the solar system into the galaxy, other galaxies, and even two galaxies are also attracting each other in the universe. Okay, there are even the telescopes views that we have seen, we are able these days that we can see that two galaxies are also colliding due to the gravitational force. So students, now this gravitational force activity even has been done by the scientists. That what experiment they have done, they have taken two 1 kg masses into the space and kept them apart to 1 meter. Okay, that 1 kg of substances are kept apart with the 1 meter, and eventually after some time they will attract it towards each other, and it took days to them to get attracted and collide with each other. Okay, that gives us an idea that yes, every object, every celestial object into this space is having its own gravitational force. That is why each and every object is revolving around any big mass. Big mass, yes. Here mass plays a very important role, because sun is having a lot of gravitational force because it is having a lot of mass, and other planets are having less mass compared to sun, so that they are revolving around it. Now you know that even in the previous chapters and in certain theories we have seen that even the meteors that are coming towards the earth planet are get deflected due to the gravity of the Jupiter, because Jupiter is having more gravity compared to the earth planet. So the meteors who probably come towards the earth now deflect its motion towards the Jupiter, because Jupiter is having lots of gravitational force and it is attracting it towards itself. That is कि हम बच जाते हैं, नहीं तो ये सारे meteors it will fall on the earth planet. Okay, and that supposedly not let us to live here. Okay, so we are very lucky that we are having Jupiter and the sun around us, and we are at the habitual zone, so that all the meteors and any other like unwanted sources, unwanted substances that are roaming into the space get attracted towards these two large masses. Okay, so this is what gravitational force, when every object in the universe attracts every other object with certain force, and that force is known as a gravitational force. We cannot see that force with the naked eye or any other thing, but we can sense it because we have seen that with a practical example. Like our moon is also revolving around the earth, like planets are also revolving around the sun, and even the galaxies are getting attracted towards each other. So in every part of the universe there is a gravitational force that is working. So students, the important question that arise here because of this is, are gravity and gravitational force same? And I have already told you that they are not same. No. So answer would be that the gravitational force means the force of attraction between any two bodies. We can take any two bodies that comes into this universe. Okay, any celestial body you can take, even you can take any of the two objects at your home, that a football and a basketball that is placing inside the two corners of your room are having their own gravitational force. They are applying their gravitational force on each other, but because they are applying the gravitational force on each other, but still they are not get attracted. Why? Because here in this case, what we can say, yes, the gravitational force is less. Like if I am talking about the gravitational force of this football and the gravitational force of this basketball is very, very less. Okay, fine. But still, if we kept them into the space, if we bring them to the space and put it there, them like a little apart, then after some time, they will get attracted towards each other and will collide. But here, why does not that happen on the planet Earth? Because the gravitational force that has been attracted by the planet Earth is more compared to the gravitational force of them towards each other. That is why they get stick. वैसे ही है बेटा, जैसे like the magnet. If you are taking a big magnet here and placing a small magnet here, okay, there is a big magnet and a small magnet, and if you are taking an iron rod or any iron thing into the next hand of yours, then it will definitely get attracted toward this, though it is nearby to this thing, but it will definitely get attracted towards this large force first. Okay, so this Earth's gravity is more compared to the gravitational force of individual balls. That is why we can say that here this will work as a greater and this will work as a smaller, but we cannot judge that, we cannot deny that the gravitational force is not here. The football and the basketball both are having their own gravitational force. We cannot deny with that. Yeah, but we can say that the gravitational force and the gravity means difference. Here gravity means the force of attraction between the earth or any other object. One more question that has been arised here is that, does gravitational force exerted by all bodies? Yes, I have told you in the earlier one also that the football and the basketball is applying their own force. But because the gravity is more compared to their individual force, that is why we cannot see that, the thing happening that these two balls collide with themselves by themselves only, like किसी ने फोर्स नहीं डाला है बट वो अपने आप एक दूसरे से अट्रैक्ट हो रही है, ऐसा होते हुए हम नहीं देख पाते. बट वी कैन नॉट डिनाई दैट द ग्रेविटेशनल फोर्स डज नॉट एग्जिस्ट हियर, इट इज एग्जिस्टिंग. Okay, so here is the thing that you can see. Let's suppose we are having a small stone and that is uplifted on the above the Earth's atmosphere. Okay, थोड़ा ऊपर हम लेकर आ गए हैं stone को. Now what happening here is the stone is having its own mass. It is having, let's suppose, m mass. Okay, and this earth is having the again a greater mass, that is the m mass. So which mass is greater, students? Obviously earth's mass is very, very big compared to the stone mass. Okay, now you know that the force that has been applied in this case is the force mass multiplied by, here I am taking the greater m, multiply by A, and here the force that has been applied because of the stone would be m, small m, and multiply by A. Okay, so you know that here the force of both, like the force that has been applied because of the stone is very less because the mass is very less here, and the force that is applied because of the earth is very big because the mass is very big here. So we can judge by this that force of the earth is greater than the force of the stone. That is why, but we cannot, like हम इससे मना नहीं कर सकते हैं that the force that is applied by the stone is not here. It is available, but the acceleration due to this force is very less. Like here, students, if we take the acceleration because of the stone, AS will be force S upon M, and in this case A earth. Okay, so FE divided by capital M here. Now, as you can see that acceleration is directly proportional here to the force applied, and here also acceleration is again directly proportional to the force applied because of the earth planet. Okay, now you can see that the earth is attracting the stone towards itself. ये earth है and it is attracting the stone towards itself, but stone is again attracting the earth toward itself. ऐसा नहीं है सिर्फ earth ही stone को अपनी तरफ attract कर रहा है, but stone भी earth को अपनी तरफ attract कर रहा है. लेकिन यहाँ पर AS, that is the FS force that has been applied by the stone, and उसकी वजह से जो acceleration produce होता है, that is very small, and that very small value is too small that we can neglect that force. But the force that has been applied because of the earth is very big that it is suddenly attracting it towards itself and it is falling on the earth suddenly. Okay, quickly ये आएगा because here the F that is applied by the earth is generating acceleration that is more because F is more. Now we can see that the stone immediately falling on the earth planet, but we cannot deny, again I am saying, the stone is also attracting the earth, but that is very little, that so little that you can take the decimal point value till crores. Okay, and that is very less value, you know that. Okay, so we can say we can neglect that thing. Okay, that is why we only see that the stone is falling towards it, not the earth is falling towards the stone.